All right. So here we are back with Google Docs. Getting started step by step, creating instances. All right. So in the previous part, we saw that a scene is a collection of nodes organized in a tree structure. Anyway, let's get back to it. With a single node as its root, we can split our project into any number of scenes. This feature helps us break down and organize our game's different components. All right. We can create as many scenes as we'd like and save them as files with the .tscn extension, which stands for text scene. The label .textScene, I don't think I'm going to remember that. I'll try to text scene file from the previous lesson was an example. We're going to call those files packed scenes, okay? As they pack information about our scene's content. Okay. Label.textScene, packed scenes. Here's an example of a ball. So it's composed of a rigid body 2D node as its root named ball, okay? Which allows the ball to fall and bounce on walls. A 2D sprite node and a collision shape 2D. Okay. So yeah, this ball has sprite 2D, which is the circle with the it's the visuals, and then collision shape 2D, which is the fact that, you know, if it touches the wall or touches this, it'll what? What'll it do? Oh, it'll bounce off something. Yeah. So once we have said, whoa, were we supposed to do something? Hold on. Were we supposed to make this? All right, well, let's keep going. Okay, so once we saved a scene, it works as a blueprint. We can reproduce it in other scenes as many times as we like. Replicating an object from a template like this is called instancing. As mentioned, okay. Anyway, as mentioned in the previous part, instanced scenes behave like a node, and the editor hides their content by default. So when we instance the ball, we only see the ball node. Notice how each duplicate has a unique name. What? What? As we mentioned in the previous part, instance scenes behave like a node. Okay, so is that what they're talking about? These are instance scenes? The editor hides their content? Okay, yeah. And then when we instance the ball, okay, we only see the ball node. All right. Notice how each duplicate has a unique name. Okay, now I get it. Okay, sometimes you got to go over it twice, right? Anyway, every instance of the ball scene starts with the same structure and properties as ball.textScene. However, we can modify each independently, such as changing how they bounce, how heavy they are, or any property exposed by the source scene. So we can change any property that they have. We'll see about that, right? I mean, okay, yeah. Anyway, let's go. Pardon me. All right, so in practice, we're going to use instancing in practice to see how it works in Godot. We're invited to download the ball's sample project that's been prepared, for us. This thing right here. So let's indeed do that. We'll click, a little come over here, and let's go up one, and let's unzip it, extract all. Where are we going to? Let's go to C. Let's browse actually. Let's browse to C, and then let's go to Godot, and that's good enough. Select folder. Boom. Extract. And there it is. Awesome. close, close. What do we want? Extract the archive on our computer. We did. Okay, cool. To import it, we need the project manager. The project manager is accessed by opening Godot. If we already have a Godot session opened, if we already have Godot open, click on project, quit project list, and that should take care of business. All right, so let's do that. Where you at, Godot? Boom. Project, quit project list. Control Shift Q. Let's do that. Control Shift Q. I don't like that. Actually, that's too dangerous. Let's actually just always do it like this if we're going to do it at all. All right, cool. So there's that. And now what are we doing? Can we read and do this? Yes. Okay, cool. Shut up. I'm making a video here. Get out of here. Come on, get out. All right, good. All right. Okay. Extract the archives. We did it. To import it, we need the project manager. We did that. All right. In the project manager, we're going to click the import button to import the project. Import right there. Let's see what we got to do after that, though. I'm going to have to do this. Whatever. All right. In the pop-up that appears, we'll navigate to the folder we extracted and we'll double click the project.godot file to open it. Okay. Import. And no, it's in C. Let's get rid of this. Let's highlight everything after that first backslash. Get rid of that. Boom. C. Godot. Here we go. Go in here. Awesome. Double click this. Double click. All right, good. Import and edit. I bet so. Warning, this project was last edited in Godot 4.2. Opening will change it to Godot 4.3. Open anyway. Project will be modified. Yes. Keep going. There we go. All right. Let's get back to the web page. All right. Did that. Finally, click the import and edit button. Good. A window notifying us that the project was last opened in an older Godot version may appear. It did. That's not an issue. Click OK to open the project. Awesome. The ball contains two packed scenes. Main.text scene containing walls against which the ball collides and ball.text scene. All right, let's go see if that's true. What? Is that true? Here's this. And here's this. I see those two things. I believe it. Let's go to 2D. Okay, I believe that. Here's this, and here's this. And a lot of other stuff, but whatever. All right, let's go back here to this. The main scene should open automatically, okay? If we're seeing an empty 3D scene instead of the main scene, click the 2D button at the top of the screen. We did that. And this is what it looks like. Let's make sure it looks like that. Indeed it does. All right. So let's add a ball as the child of the main node. In the scene dock, we'll select the main node, then click the link icon at the top of the scene dock. So this one right here. This button allows us to add an instance of a scene as a child of the currently selected node. Okay, we will do that. And then we'll double click the ball scene to instance it. Okay, so that's what we'll do. Write this instance. All right, instant. Was it instant? Write this instant or write this instance? Write this instant. Of course, never mind. Disregard that. That wasn't good. All right, so now we're at what we were doing. This thing, which is this thing. All right, let's do it. Here we go. And main? Wait, what? What'd you want? Ball. Okay, we can do that. Boom. All right, so we got this. Let's see what you got now. So the ball appears in the top left corner of the viewport. It sure did. Click and drag it toward the center of the view. Okay. We did something kind of like that. Play the game by pressing F5 and we should see it fall. You don't got to tell me twice. All right, F5. There it goes. Right in the middle. I wonder if it'll do it again. Why does this keep doing that? I guess it's every time it runs a program, the computer runs a program, this happens. That's so annoying, isn't it? Welcome to Windows. I guess they don't have this problem on Linux, huh? Tough shaboinkers. So let's F8 that. What a problem. What a problem. What a first world problem. What a computer programmer problem. All right, let's yeah. What are we doing? Coming over here? Yeah. All right, so now we want to create more instances of the ball node. With the ball still selected, we'll press Control D on Mac OS to call and duplicate, to call the duplicate command. The duplicate command. Okay. So we're calling the duplicate command. Is that what duplicate it? Duplicate. Okay, it's got to be duplicate. So click and drag to move the new ball to a different location. That's what we'll do. What was it? Control D? Gotcha. All right. Click it. Control D. Duplicate. We saw that happen. We got ball 2 right there. Boom. We got ball 2 right there. Let's press F5. Cha-cha. There it goes. What happened in NVIDIA? Oh, no. You didn't fail to disappoint. Let's see. Okay, you saw them. It's going to do the exact same thing every single time, no matter what we do, because the math is the exact same every single time. Let's go. All right. Was I supposed to do that? Yes. Okay. Let's go. Here it is. All right. So we did that. Now we're doing the next thing. We can repeat this process until we have several in the scene. We can do that. And we will. All right. Click this one. Control D. 1, 2, 3. 1, 2, a 3. Let's do that. Let's do that. How about that? Let's run it. Come on, NVIDIA. NVIDIA. Cool. All right. F8, and it'll do the exact same thing. Remember that thing that happened right at the end? Every single time. Every single time it'll do it. Don't gamble against this happening. Do not. You will lose your money. Oh, you think? Nope. Every single time. Can you imagine somebody saying, I bet it won't? That'd be crazy. Anyway, wouldn't that be crazy? If somebody would say that, you got like $20 off them, like just because it's so dumb. Anyway, let's go. Play the game again. We should now see every ball fall independently from one another. We did. And this is what instances do. Each is an independent reproduction of a template scene. Gotcha. Editing scenes and instances, okay? So there's more to instances. With this feature, we can change the properties of one ball without affecting the others using the inspector, okay? We can change the default properties of every ball by opening the ball.text scene and making a change to the ball node there. Upon saving, all instances of the ball in the project will see their values updated. Yeah, so if you change something and then save it, you know, if you change it high enough in the tree or hierarchy, whatever you want to call it. Do they not want to call it hierarchy? Whatever. Anyway, blah, blah, blah. Upon saving, blah, blah, blah. Upon saving all instances of the balls. Yeah, of course. Okay, note, changing a property on an instance always overrides values from the corresponding packed scene. Changing a property on an instance always overrides. Okay, changing property on an instance. Oh, yeah. Obvious. Yeah, definitely. Always overrides values from the corresponding packed scene. Definitely. Because Look, let's see. Like if I change this to do something over here, gravity scale, let's say gravity scale. Which ball is this? Let's do it for this one. No, let's do it for this one. This one. Ball. And then let's like add some gravity. Can we do this? Can we do this? 10. I mean, we're going to do this later, but I'm going to do it now too. And then press F5. Watch this one. This is the one. Boom! Much different than when it was at 4. Let's undo and then run it. And then it's just a little bounce. All right, so yeah, let's get rid of that. So that's what they're talking about when they're saying if you change it on the node, on the little node here, it won't change it everywhere else. But this does. But whatever you change here overrides everything else. All right, so back to where we were here. All right, we're gonna try this. We're gonna double click ball.tucson in the file system to open it. Text scene, my bad. Okay, click that. Select the ball node in the inspector on the right and click the physical property. Okay, to expand it. So this thing. It's basically the same thing we just did, but different. All right, so we're on ball right here. And then let's do physical material. Was this what it wanted? Yeah, this thing. Okay. Was that what it wanted? It's gotta be. Anyway, and then let's do the next thing. Set the bounce property to 0.5 to 0.5 by clicking on the number field and typing 0.5 and then enter. Let's do that. Bounce right here. 0. Whoa, whoa. What are you doing? Why is this not? What's up with that? What's up with that? What's up with that? Bounce. Can we change it now? Or do we? Excuse me? Okay. Is there a reason we couldn't and now we still can't? Double click this in the file system to open it. Okay, we did that. Select the ball node. Is it supposed to look like is it supposed to look just like that? Anyway, let's try it. Select the ball node. We did that. And then we come over here to physical material. Click that. And then there's a bounce right here. And we say 0.5. Okay, so that was the thing. We needed to double click the thing. My bad. It was my bad. Sometimes that happens. And then it does it just like that. Pops around. Bops, bop, bop, boop, boop. One of them flew off the screen. Looks good to me. Let's get rid of it like that. All right, so let's go back to the thing. I might have to edit that out. We'll see. Or at least a lot of it. So we played it again, and now we saw every ball fall independently of one another. And this is what instances do. Each is an independent reproduction of a template scene. Okay. Editing scenes and instances. No, we already read that. Okay. Okay, here we are. So play the game by pressing that. We did it. Okay. Bounce a lot more. Okay, we saw it. As the ball scene is a template for all instances, modifying it and saving causes all instances to update accordingly. Okay. So now we're going to adjust an individual instance. All right. We'll head back to the main scene by clicking on the corresponding tab above the viewport. This one right here. So we'll come here. We'll do bop like that. Then we'll come back here and see what they want us to do next. So we're going to select one of the instanced ball nodes, and in the inspector, we'll set its gravity scale to 10 like we did the first time. All right, so we'll come over here, boom, get one of these. How about ball one again? And then we'll set this one to gravity scale. Do we got to double click it? I don't think so. Let's say 10. Enter. And it's this ball right here with the little cross in the middle of it. Little crosshairs. Let's go and say F5. Pew! Oh, they all made it in though. Let's do it again. That was pretty dramatic. Let's do another. Boom! You saw that one? Pow! Let's do it one more time. Boom! Boom! One more time, right here. Boom! Just like that. That's awesome. All right, I'm glad that happened. It's real good for the video. Let's go to the next part. Select one of the instance ball nodes and do that. We did it. A gray revert button appears next to the thing. So we can revert it if we push that. Let's go do that. Let's go do that right now. Let's, where are we? Here, revert. Okay, let's do a Control Z and it puts it back there. All right, cool. Back to this. We could have just pushed Control Z anyway and it would have taken this back. No big deal. All right, no big deal. All right, so let's come over here and see what's next. So this icon indicates we're overwriting a value from the source packed scene. Even if we modify the property in the original scene, the value override will be preserved in the instance. Yeah, so later after you do like a million things and you want it to revert back, you can do that. All right, great. Clicking the revert icon will restore the property to the value in the saved scene. I think that's great. We're going to rerun the game and notice how the ball falls much faster than the others. We saw it. It was great. Note, we may notice that we are unable to change the values of the physical material of the ball. No. This is because physical material is a resource. What? It needs to be made unique before we can edit the scene that is linking to the original scene. What? Oh, all the rest of this stuff. I see. Oh, we can't, can we not even, yeah, we can't change this stuff. All right, let's go back and see what it was saying. Made unique before we can do that. To make a resource unique for one instance, we can right click on the physical material property in the inspector and click make unique in the context menu. Resources are another essential building block of Godot games that are going to be covered later. So let's do this make unique thing here. And then let's go here, right click here, make unique here. And now we can mess with this stuff. This is on this ball. I shot this one there. Let's see what we can do on this one. Go. Ah, it's the same bounce. Is that not good enough? Was that not cool enough? What the? It's the same bounce. It looked like the same bounce. Let's do a Control Z. Yeah. And now let's send it off. Send it to the moon again. It's the same bounce. It's the same bounce. What are they talking about? What are they talking about? We changed it and didn't do anything. Same thing. Or is it different? Okay, look, let's look over here. Maybe it's different. Okay, let's run again. Okay, did you see that little violent thing? Let's do it again and send it again. There, that one. Let's see if. All right, that thing. We're gonna look for that in this one. Run it. It was still there. It's the same bounce. Okay, I don't know what they're talking about. I don't know. We'll get to the bottom of this at some point, but that point is not this point. Let's go to this. Actually, let's go to this and press Control Z again, and then let's go to this. All right. It's kind of annoying though, I'm not gonna lie. Scene instances as a design language. Okay. So instances as scenes in Godot offer an excellent design language, setting the engine apart from others out there. Okay. They designed Godot around this concept from the ground up. So instances and scenes in Godot offer an excellent design. Yeah, of course. I think it's a nice language. GD script. They recommend dismissing architectural code patterns when making games with Godot. I don't even know what that means. Such as model view controller. I don't know what that means. Or entry relationship diagrams. Instead, I don't know what that is either. Instead, we can start by imagining the elements players will see in our game and structure our code around them. Okay. For example, we could break down a shooter game like this. The stage, I guess that's the complete environment, and there's going to be the player ship. So it's going to be like a Galaga, like a spaceship flying around, and it's going to have a weapon. And it's going to probably shoot the weapon. That's what the instance by code is. Probably shoot the weapon, I guess. I don't know. There's going to be an enemy. There's going to be an obstacle for the ship to go around. There's going to be the HUD, like the health here and, north, south. I don't know. Whatever would be on the heads-up display. Market, I don't know what that is. Maybe they're talking about the microtransactions. Yes, we're gonna get into this big time one day, soon enough. Oh, and then there's an enemy, and this one's actually firing, and that's all you see on the stage. I guess that's cool. I don't have a problem with that at all. I don't have a problem with that at all. I think that's cool. We can come up with a diagram like this for almost any type of game. Yeah, we could actually, if we really think about it. We really could. Like a first-person shooter, we could say, instead of player ship, we could say gun at the bottom of the screen with a hand that comes up sometimes, and like a weapon and the animation, whatever. Yeah, we could do that. All right, so let's go. So we can come up with a diagram in a game. Each rectangle represents an entity that's visible in the game from the player's perspective. True. The arrows tell us which scene owns which. True. This right here, microtransactions. That's how we're gonna get these light bills paid one day. We can come up with a diagram like this for almost any type of game. Each rectangle represents an entity that's visible in the game from the player's perspective. The arrows tell us which scene owns which. Okay, we said that. Once we have a diagram, they recommend creating a scene for each element listed in it to develop our game. A scene for each. Oh, yeah. We'll be instancing. We will use instancing either by code or directly in the editor to build our tree of scenes. Okay. It's recommended that we create a scene for each. Remember, the weapon itself is a scene. The HUD is a scene. Everything's a scene. Remember, that's what they said earlier. Programmers tend to spend a lot of time designing abstract architectures and trying to fit components into it. I don't know what that means. Designing based on scenes makes development faster and more straightforward, allowing us to focus on the game logic itself. Because most game components map directly to a scene, using a design based on scene instantiation means we need little other architectural code. Excuse me? What? Excuse me? What was that? What did you just say to me? Designing based on scenes makes development faster. Okay, so doing what this thing makes it faster, more straightforward, allowing us to focus on the game logic itself. I'll take their word for it, because most game components map directly to a scene. Using a design based on scene instantiation means we need little other architectural code. I don't know what that means at all, and let's just keep going. Here's the example of a scene diagram for an open world game with tons of assets and nested elements. We've got it. Okay, actually, look. See which way these things are going. I mean, Of course, I would love to read it left and right, but that's not really what's going on here. We're starting with the vase, and then we're making the vase. We'll make a vase, and then the vase will be on a table, and there'll be a chair next to the table somewhere in the room that we're going to be making, right? And the room has a door with it, and this door connects it to the house. And the house is in a citadel, and there's also a church with a seat in it. And there's also in this next to the around the citadel, there's a bridge with guards on it. And there's also the player somewhere in there with the heads up display, and there is terrain there that everything's on. Okay, so that's how that chart's working. Well, imagine we started by creating the room. We could make a couple of different room scenes with unique arrangements of furniture in them. Okay. Later, we could make a house scene that uses multiple room instances for the interior. Yeah, we could do that. We could do that. Like 3 rooms and doors in the house or whatever. Maybe just anyway, whatever. It doesn't matter. We would create a citadel out of many instance houses in a large terrain on which we would place the citadel. Each of these would be a scene instancing one or more subscenes. Yes, absolutely. 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 We can do that. We can do that. Oh man, we could do that. We could do all kinds of stuff. I'm just thinking like a top-down Zelda, like Zelda NES game style. We could do that. Oh, it would be so good. Later, we would create scenes representing guards and add them to the citadel. Sure. They would be indirectly added to the overall game world. Sure. And then the other thing about this is probably why a lot of those games start you off in a room, right? Because that's the first thing that's encoded or something. I don't know. And that's what we're going to do. We'll be cliche. It doesn't matter. No big deal. With Godot, it's easy to iterate on our game like this, as all we need to do is create and instantiate more scenes. Makes sense. They designed the editor to be accessible to programmers, designers, and artists alike, and we're going to have to be all 3 in one. A typical team development process can involve 2D or 3D artists, level designers, game designers, and animators, all working with the Godot editor. True, but I want to know all this stuff, so because I assume I'm guessing that you want to also, so we are going to do everything. So here's the summary. Instancing the process of producing an object from a blueprint has many handy uses. True. With scenes, it gives us the ability to divide our game into reusable components. True. A tool to structure and encapsulate complex systems. Yes. And a language to think about our game project's structure in a natural way. Yes. So we can have a bunch of different rooms. We can have a tool to do the whole system, not just the components, but everything, even the when to animate and when not to, and a language to do this stuff. All right, great. Now I went through a few of these, and you should too. All right, so let's go next. All right, so now we're on to scripting languages, and we'll see you next time.